Okay, I'm going live. My name is Verde Arbusto, and this is the Schumann Resonance Harmonics channel on YouTube. It is the 28th, I guess. I'm at the 28th of Tuesday, January of 2020. And I'm going to pick up where I left off last time, and that's on frequency. I'm glad that the camera stopped when it did, because frequency is something that I need to take time to discuss by itself. You're looking at a map of, or not a map, but it's a basic illustration. It's an example of the Schumann Resonance's reports. So where we were at, I'm glad I have a chance to discuss frequency by itself. The video I made before this kind of shut off before I was not able to discuss frequency. And of all the things that's important for people to know about the Schumann, frequency is the most important part of this. People talk about frequency and relative to the human and the Schumann, and they don't exactly know what frequency is. That's quality. All right, frequency. Yes. All right, and the screen capture is from disclosurenews.com. I think it's important to mention that. All right, so right here we have our frequency. Okay, so the frequency that we are looking at here in this dependency is the wavelength. This number right here, this is 8.2. This is 8.2, and that number there. And this right here, this number is 7.34. All right. So this is mode 1, the white one. You see this, all these up and down the jaggeds. All right. The white one is mode 1, that says F1 right there, frequency 1, and then you have frequency 2 here. Frequency 2 is the yellow. It goes from 13 to 1460. All right. So you notice the demarcations of 1734 to 806. So that's what? That's 60. That's 66. If my math is good. That's 0.66 lines demarcation in that space. And here, from 13 to 1460, that same amount of space is 1.6. And then you have over here at frequency 3, the red, it goes from 10, looks like 1070 up to 2050. So that's a demarcation of 10. And then you have the green mode, which starts here at the frequency of 2420 to 2640. What you're looking at here at the frequency is the wavelengths themselves, period. This dependency is not the frequency of the Schumann harmonics or the Schumann resonance harmonics. This is the individual waves that it is measuring. The antenna, the induction coil, is measuring these waves. Okay. So you'll notice the frequency kind of has these nice up and down lines, like that. They're all sort of doing that. That is the periodicity of the frequency. Okay. Let it's important to understand the differences between the frequencies that we're talking about here. Let's see if I can scoot in here. There we go. All right. So, frequency of this dependency is basically the volume. This is measuring the size of the wavelengths in kilometers. Okay. So, the ULF, which is the ultra low frequency range, is between 0, or it's actually 3. I think it's 3 to 30 cycles per second. in this, the white here, you see the wavelength is at 734 up to 820. When we talk about resonances, we are not talking about the wavelengths themselves. The resonance of the harmonics is the interference. The frequency of standing waves is the interference. It is the difference between the frequency of the two waves. So, as you see, the yellow and the white, they're very close, but there is a difference between the frequencies between the two. So as these waves are bouncing around, bumping into each other, the difference between, say this one here is 8.2, and this one here is 14.6. Oh, sorry. You go over to this line here, you see the height, 1460. This line, 1460, this is the yellow mode. That's mode 2. It's the same thing here. You look at the height of the frequency here at the same time. That's at 20.9. It looks like 20.9. All right. So the height of this is 20.9. The height of the frequency, mode 2, is 14.6. And the height of the mode of frequency 1 is 8.02. In the same place. You see, tick, 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 right there. There was not necessarily a peak there at mode 1. I'm sorry, mode 4. I'm talking about the green, mode 4. So you see it's not quite the same peak on the rising. The green mode is the heaviest and the widest of the waves, so it's sort of peaking after. Right? There's not a peak there. You see the peak here reaches that peak, and then after that, all right. So you see they're all bouncing all over the place. But essentially, we have them lined up. They're all basically in the same peak area here, this range here. So the peak, I would say, of the white mode hit here, and the peak of the green mode hit a little bit after it. Like, I don't know, half an hour, maybe, I think it was, later. So you can see the difference in the frequencies, that as one is moving one way, it's kind of on the upswing, and the other is on the downswing. They bump into each other, and that's what gives you the frequency and the resonance. Okay. Now, this is measuring more of the volume. It's not measuring the speed. There's a lot of confusion when we talk about the Schumann resonances and what frequency means. All right. So here we have a resonance. This is what a resonance is. It says increase of amplitude as damping decreases and frequency approaches. Resonant frequency of a driven damped simple harmonic oscillation, that's essentially what these are harmonic oscillations.